Good morning. Today I will explain how a neural network works using a visual tool. This helps us clearly understand how models learn patterns from data, which is useful in applications like radar. Signal classification. A neural network is a mathematical model inspired by neurons in the human brain. It learns patterns from input data instead of being explicitly programmed. In defense systems, this is useful for identifying target signal patterns and anomalies. Dataset different patterns, circle, spiral. Training versus testing split noise present. Here we see the dataset. The model is trained on part of the data and tested on unseen data. Noise represents real-world uncertainty, like interference in radar or sonar signals. Input features. X1, X2, X1 superscript 2, X2 superscript 2, X1, X2, sin X1, sin X2. Features are inputs to the model. Basic features may not be enough for complex patterns, so we add derived features like squares and sine functions. This is similar to extracting meaningful parameters from radar returns. Neural network structure input layer. Hidden layers. Output layer. The input layer takes data, hidden layers process it, and the output layer give the result. Each connection has a weight, which the model learns during training. Hidden layers. Multiple layers, deep learning. Neurons in each layer. Hidden layers enable the model to learn complex relationships. Increasing layers improves learning capability, but also increases computational complexity, which is important in real-time defense systems. Activation functions introduce nonlinearity. Without them, the model cannot learn complex patterns. TAN helps in smooth classification boundaries. Learning process. Epochs. Learning rate. An epoch means one complete pass through the dataset. Learning rate controls how quickly the model updates. In practical systems, choosing the correct learning rate is critical for stability. Loss. Training loss. Test loss. Loss measures error. Training loss shows performance on known data, while test loss shows generalization. Low test loss is important for real-world deployment. Weights visualization. Blue, positive. Orange, negative. Thickness, strength. This visualization shows how strongly neurons are connected. Stronger weights mean higher influence on output. This helps in interpreting model behavior. Conclusion. Learns patterns from data. Useful in defense applications. In summary, neural networks are powerful tools for pattern recognition. They are widely applicable in radar and sonar systems for classification and decision-making.